So here we have the function sine squared t, and we need to determine the Laplace transform of the given function. Now before that, we are going to simplify the given trigonometric function. So we are going to use the identity that cosine of 2t is equals to 1 minus 2 sine squared t. So if we are going to only use the sine squared t function, so we can rewrite it as sine squared t is equals to 1 minus cosine of 2t divided by 2. So that means our function f of t is half of 1 minus cosine of 2t. So let's now find out the Laplace transform. So Laplace transform of f of t will be simply equals to half multiplied to the Laplace transform of 1 minus the Laplace transform of cosine 2t. Now here we have used the linearity property of Laplace transform, which gives us half times Laplace transform of 1 is 1 over s minus Laplace transform of the cosine function is s divided by s squared plus a squared. So a here is 2, so we have 2 squared. So that gives us half multiplied to s times s squared plus 4. So in the numerator we have s squared plus 4 minus s squared. So the s squared and negative s squared gets cancelled, leaving us with 4 in the numerator. So we can also cancel out 2 from the denominator, and 2 times 2 is 4. So that leaves us with 2 divided by s times s squared plus 4. So this is the Laplace transform of sine squared of t, and this transform is going to exist for s greater than 0. Let us go to the next question. So now we have to determine the Laplace transform of cosine squared of cosine squared of t. So we're going to use the identity that cosine of 2t is equals to 2 times cosine squared t minus 1. So if we arrange the terms, then we have cosine squared of t equals to 1 plus cosine of 2t divided by 2. So that means our function cosine squared of t can be rewritten as half times 1 plus cosine of 2t. So let's find out the Laplace transform of the function f of t. So that is equivalent to saying half times the Laplace transform of 1 plus Laplace transform of cosine 2t. So we have half multiplied to Laplace transform of 1 is 1 over s plus Laplace transform of cosine of 2t is s divided by s squared plus 2 squared, which is 4. So that gives us half multiplied to s times s squared plus 4, and in the numerator we have s squared plus 4 plus s squared, and that's going to give us 2 times s squared plus 4 divided by 2s times s squared plus 4. Now we can take 2 as the common factor from the numerator, so we have 2 times s squared plus 2 divided by 2s times s squared plus 4. So we can cancel out 2 from both the numerator and the denominator, and that leaves us with s squared plus 2 divided by s times s squared plus 4. So this is the Laplace transform of cosine squared t, and this is going to be valid for values of s greater than 0. Let's go to the next question. So here we have the function cosine squared at. Now this problem is quite similar to the previous one. We had cosine squared t. So we know that cosine of 2t is equals to 2 times cosine squared t minus 1. Now we're going to substitute t with at. So our identity becomes 2at equals to 2 times cosine squared at minus 1. Now solving for cosine squared of at, we get 1 plus cosine of 2at divided by 2. So that means our function can be also written as half multiplied to 1 plus cosine of 2at. Now let's try to find out the Laplace transform of our function f of t. So we have half multiplied to the Laplace transform of 1 plus the Laplace transform of cosine of 2at, which will be equals to half multiplied to Laplace transform of 1 is 1 over s plus Laplace transform of cosine 2at will be s divided by s squared plus 2a whole squared. So 2a whole squared will be 4a squared. Now let's combine the two terms. So we have half multiplied to s times s squared plus 4a squared in the denominator, and in the numerator we have s squared plus 4a squared plus s squared. So that gives us half. So we have s squared plus s squared, so that will be 2s squared plus 4a squared divided by s times s squared plus 4a squared. Now we're going to divide both numerator and the denominator by 2. So in the numerator we have 2s squared divided by 2, so that will be s squared plus 4a squared divided by 2, so that will give us 2a squared whole divided by, so we already have a 2 in the denominator, so divided by 2 will give us 1. So we have s times s squared plus 4a squared. So this is the Laplace transform of the given function cosine squared of at, and this is going to be valid for s greater than 0. So let's write it down. So Laplace transform of cosine squared of at is equals to s squared plus 2a squared divided by s times s squared plus 4a squared. Now let us suppose that the value of a is equals to 2, then Laplace transform of cosine squared 2t, so that will be equals to s squared plus, so 2 times 2 squared, so 2 squared is 4 and 4 times 2 is 8. So we have s squared plus 8 in the numerator divided by s times s squared plus 4a squared, so a squared is 2 squared, so 4 times 4 is 16. So this is the Laplace transform of cos of square 2t. If we take a is equals to 4, then that gives us Laplace transform of cosine squared of 4t. So this will be equals to s squared plus 2a squared, so 2 times 4 squared, so 4 squared is 16, 16 times 2 will be 32, divided by s times s squared plus 4 times 4 squared, so 4 squared is 16 and 16 times 4 is going to give us 64. Similarly, we can check out for a equals to 1, so that will be Laplace transform of cosine squared t, and this we have already done in the previous problem. So we can verify that this value will be s squared plus 2 times 1 squared, so that will be simply 2. So s squared plus 2 divided by s times s squared plus 4 times 1 squared, so that's simply 4. So this is how we find out the Laplace transform of cosine squared at. Let's move on to the next question. Similarly, we're going to figure out the Laplace transform of sine squared at. So we start with the identity cosine of 2t is equals to 1 minus 2 sine squared of t. So if we replace t by at, so we get cosine of 2at will be equals to 1 minus 2 times sine squared at. Now we solve for sine squared at, so that gives us sine squared at is equals to 1 minus cosine of 2at whole divided by 2. So that means our function is equivalent to half multiplied to 1 minus cosine of 2at. So let's try to find out the Laplace transform of the given function. So Laplace transform of f of t will be equals to half multiplied to the Laplace transform of 1 minus the Laplace transform of cosine of 2at. So we have half multiplied to Laplace transform of 1 is 1 over s minus Laplace transform of the cosine function will be s divided by s squared plus 2a whole squared, so that will be 4a squared. So let's combine the two fractions. So that is going to give us s times s squared plus 4a squared in the denominator, and in the numerator we have s squared plus 4a squared minus s squared. So the s squared and s squared gets cancelled, so we have 4a squared divided by 2, so that will be 2a squared divided by s multiplied to s squared plus 4a squared. So this is the Laplace transform of the function sine squared at. And the Laplace transform is going to exist for the values of s greater than 0. Now let's consider some different values of a. So we have already done, if we consider a to be equals to 1, so that is going to give us the Laplace transform of sine squared t. And we've already done this problem, so this will be 2 times 1 squared, so that is 2 divided by s times s squared plus 4, since a squared is 1. So for a equals to 2, so we're going to get a Laplace transform of sine squared 2t. So that will be equals to, so we have 2 times a, which is 2, so it is 2 squared, so 4, 2 times 4 is going to be 8, divided by s times s squared plus 4 times 2 squared, so 4 times 2 squared is 16. So this is the Laplace transform of sine squared 2t. And if we consider a to be equals to 4, then we have Laplace transform of sine squared 4t. So that will be equals to 2 times 4 squared. 4 squared is 16, so 2 times 16 will be 32, divided by s times s squared plus 4 times 4 squared, so that will be 64. Similarly, we can also find out the Laplace transform for e equals to 3, so that is the Laplace transform of sine squared 3t. So that will be equals to 18 divided by s times s squared plus 36. So this is how we can find out the Laplace transform of different functions for different values of a. Let's do another problem. So we have the function sine squared t times cosine squared t, and we need to find out the Laplace transform of the given function. So what we're going to do, we are going to first simplify the given equation. So we can rewrite it as sine of t times cosine of t whole square. Now we're going to multiply the function within the parentheses by 2, and also we're going to divide by 2. So we have half multiplied to 2 times sine t times cosine of t whole squared. Now, this has been done because we know that 2 times sine of t times cosine of t is an identity which is equals to sine 2t. So we have half sine of 2t whole squared. So what that gives us 1 over 4 times sine squared 2t. Now we know that cosine of 2t is equals to 1 minus 2 sine squared t. So if we change t by 2t, then we get cosine of 4t is equals to 1 minus 2 times sine squared 2t. So solving for sine squared 2t, so we get sine squared of 2t, it will be equals to 1 minus cosine of 4t divided by 2. So that means our function will now become 1 over 8 times 1 minus cosine of 4t. So let's now find out the Laplace transform. So Laplace transform of our function f of t, that will be equals to 1 over 8 times the Laplace transform of 1 minus the Laplace transform of cosine of 4t, which will be equals to 1 over 8 multiplied to Laplace transform of 1 will be 1 over s minus Laplace transform of cosine of 4t, so that will be s divided by s squared plus 4 squared, so that is 16. We combine the two terms, so we have 1 over 8 multiplied to s times s squared plus 16, and the numerator we have s squared plus 16 minus s times s, so that is s squared. So s squared and s squared gets cancelled. We have 16 in the numerator, which is divided by 8 in the denominator. So 16 over 8, that will be 2. So we have 2 over s times s squared plus 16. So this is the Laplace transform of the given function sine squared t times cosine squared t, and it's going to be valid. That means the Laplace transform is going to exist for the values of s greater than 0.